where we've been dealing with graphs of sines and cosines. Today what we'll do is we will combine everything together in regards to our graphs of sines and cosines. If you've struggled a little bit in the last couple of days with picking it up and getting enough practice, we will get enough practice in the next couple of days of everything combined together. I would be utilizing the exact same cues as I did yesterday and the day before, but we will just once again lump everything together. And as you go along here, you'll get better and better at in regards to the graphing, just because you're going to have more and more practice with respect to it. Is there any quick questions that you have in regards to dealing with phase shifts, working through the idea of phase shifts? And once again, today, if you're off just a little bit and you're not quite there, what we go through today will shore things up for you. Okay, we have a very general equation that I will continue to refer back to. We have y is equal to vertical phase shift plus our a, which is our amplitude, sine or cosine b, theta minus our horizontal phase shift. A, once again, is our amplitude. A is our amplitude, our distance to our peaks and our valleys. I should put an absolute value there. Our distance to our peaks and valleys from our neutral axis. That is our amplitude. Period. Is calculated by 360 divided by our b value. The period is the number of degrees of the cycle. It is also the number of degrees to another point where the graph will start to repeat itself again. Our vertical phase shift will give us our prime axis, which is your neutral axis. It is the axis that you'll oscillate about. You will go amplitude up from it, amplitude down from it. Okay, so this is your prime axis. Your prime axis is the first thing that we're going to look at, and we're going to look to put into the graph. This is always numero uno, the first thing that you're going to put onto your graph. The horizontal phase shift will give you a theta start value. This, along with our trig function, will tell us where to start our graph at. This is the second thing we look at. So when we first put our prime axis in there. The second thing we're going to go to is we're going to go to the horizontal phase shift, which will give us a theta start value. We will go to sine and cosine. That will tell us if we're going to start at a peak or valley or on the prime axis. If we have a sine curve, if we're dealing with a sine curve, we will start on the prime axis. If we have a cosine curve, we will start at a peak or a valley. How do we know if we start at a peak or a valley? This is a positive A, we're at a peak. If this is a negative A, we are at a valley. If we're positive with the sine, we'll start here. This will be our positive sine. We'll go up first. We'll climb the hill first. Then we go into screen mode. If we are a negative sine, we will go down first and then up. These will be the guides that we will use each and every time. I will give you these cues and we will walk through these cues every time as we go through the problem. It's not going to change. Everything we'll do will be very, I do this first, I do this second, I do this third. Okay, very prescribed in what we're going to do. The one last thing I'm going to ask you to find is called the y-intercept. I'm going to ask you to take your graph back to the y-intercept. The y-intercept is the point where the graph crosses the y-axis. I'm going to ask you to find the y-intercept and take the graph back to that y-intercept if it's not there already or indicated on your graph. The point where the graph crosses the y-axis. And how we calculate this is we put our theta value equal to 0. Okay, this is a clickety-clack exercise through the calculator. So when we approach a problem, we first get our pertinent information. We get the amplitude, we get the period, we get the vertical phase shift, we get the horizontal phase shift. We'll talk about the y-intercept here first, or when you get done with that. Get your amplitude, period, vertical, horizontal phase shift. Check your answer with somebody with around you. It's just the amplitude period.
3.
180. Taking 360 divided by 2. 180. L vertical phase shift, horizontal phase shift.
60.
Yes, no with a 60. Negative 60. Okay, we have to look to see what is being subtracted from theta here. The value that's being subtracted from theta is negative 60. Okay, so in your mind, what you have to go into is the idea, when I have a plus there, it's a minus. When I have a minus there, it's a plus. Okay, the y-intercept. Y-intercept is where theta is equal to 0. So what I typically do is do some mental math here. If I put 0 in for theta, I have 0 plus 60, which is 60. And I have to multiply that by 2. So in my calculator, I got 2 times 60. If I want to keep it that way, that is fine. I have I have 2 plus 3 sine. 2 plus 3 sine. If I want to, 2 times 60. Close your parenthesis out. If you want to do the mental math and say that's 120, that is fine. If you want to go 2 times 60, that is fine. And hit enter. So you get 4.6. Once again, I want your graph taken back to that, or it should cross close to where 4.6 is. Now, if we take a look, once again, this is somewhat of an acquired thing as you go through the graphs. I got a vertical phase shift of 2, which means my graph is going to get shifted up 2, and I have an amplitude of 3. So I need to make sure I get up to about 5 or 6 there. Don't have to go very far down below. I have a horizontal phase shift of negative 60. So I'm going to make this a little top heavy here. Doesn't have to be anything major, but a little bit top heavy here. Okay, I don't want to, and if you, put it here, and you're going to have to go up to 5, you're going to maybe run out of room. So that's why I say you make this a little bit of little top heavy. Make sure you label your axes. We have theta and y. The period is 180, and I have a vertical phase shift to negative 60. So I can make my 90s a little bit bigger. So I'm going to make my 90s a little bit bigger. And then I can divvy these into thirds. So typically I count out my 90s and divvy into thirds or halves if I need 45. I need to make sure I stretch up to 5. Like I said, that's why I make that a little top heavy. As we continue to go through this, the better you will get at this aspect. Once again, make sure you have straight edges or making straight lines. I will take points off. If you don't label your axes, I will take points off if you don't use a straight edge. All right, first thing we look at is the vertical phase shift. First thing, tells us where we're going to put our prime axis. So at a value of 2, I'm going to draw in theta prime. Once again, this gives us a line that will oscillate, that we will go up from, we will go down from. The second thing we take a look at is our horizontal phase shift and our trig function. Our horizontal phase shift tells us where we start, our theta start value. So we're going to start at negative 60. Our sine or cosine will tell us, do we start at peaks and valleys or on the prime axis? Well, we have a sine curve, so we're going to start on the prime axis. So at negative 60, we start on our prime axis. Third thing we look at is where do we end up at? Every 180 degrees, we will be at the exact same spot. So if we start at negative 60 and we go 180 degrees to the right, we will be at the exact same spot. Every 180 degrees, we'll be at the exact same spot. Well, if I start at negative 60 and I go 180 degrees to the right, where are we at? 120 degrees. I will be at the exact same spot. Now we play our games of halves. Halfway between negative 60 and 120 degrees. So we add those two together, divide by 2. Or if you can do some mental math, that is fine. 30 degrees. Now the question is, where are we at with our y value? Well, with a sine curve, once again, with a sine curve, we start on the prime axis, we climb, we click, then we scream, go below the y-axis. Okay, so at the value of 30, what is our y value going to be? 2. We'll be on the prime axis again. Games of halves between negative 60 and 30. Add them together, divide by 2. Look us where we at. Negative 15. So here's our negative 30, so we're halfway here, negative 15. What's our y value going to be? Now our y value, we have to go to a peak. Our gains of halves here, we're going to have to go to a peak. Well, here's our prime axis at 2. My amplitude is a value of 3. So what would be our y value? No, not 3. 5. I have to go 3 up from the prime axis. So we're at 5. Then halfway between 30 and 120. Rachel, where are we at? 75. What do you think our y value is? Now not 5. We click, and we climb the hill. Then we go into scream mode. Ah! Negative. Now, we have to go 3 down from 2. Not negative 2. Getting close. There we go. You're getting warmer. Negative 1. Now, if I place my y-intercept in there at 4.6, which is right about there, I put my y-intercept in, my graph will go through that y-intercept, or close to it. The process we go through there, going to be the same each and every time. Find your amplitude, period, vertical, horizontal phase shift, and y-intercept. Okay, the Farnsworth amplitude period.
2 and 720.
710 and 20, taking 360 divided by a half, we get 720. Okay, 360 divided by half, 720. Vertical horizontal phase shift. Maddie, what do you have? That is correct. And then our y-intercept. What do we come up with our y-intercept? Well, we have -1 plus 2 cosine 0.5 times 90. Close your parenthesis out. Jade, what do you have? 0.4. Good with those values? Okay, now let's take a look at our graph. Vertical phase shift of -1, amplitude of 2. Don't have to be really top or bottom heavy. I could pretty much be right in the middle with my graph. Now my spacing on the theta axis, the period's 720. So I need to make my 90s a little bit smaller. Once again, as you do more and more of these graphs, you'll get better at being able to get your graphs down. I would suggest getting some decent space, just a little bit of decent space in there. Don't scrunch it all together, because it makes it a lot more difficult for you to be able to get a graph down. Of course, it's harder on the old man eyes too, for me to look at what you're doing. First thing you're drawing your prime axis. So -1, draw on your prime axis. Second thing, horizontal phase shift in our trig function. -90 tells us our theta start value. Sine or cosine? Okay, we have a cosine here. Are we going to start on the prime axis, or do we start at peaks and valleys here? Jaden, where are we going to start at? Peaks and valleys. So we have a positive cosine. Let me draw my prime axis here. So we're going to start at -90. Okay, with our theta start. Cosine, you said we started at a peak or a valley, so we have to go to it's a positive cosine, we're going to be at a peak. So where would be our peak from our prime axis with an amplitude of 2? Jade? Not up to 2. We start at -1, and we have to go up to 1. So we'll be up at 1. So when you have a cosine curve, you have to go to the amplitude also. Now, the third thing we look at is the period. Tells us where we will be at the exact same spot and what degree measure. Well, if I start at -90 and the period is 720, what degree measure will we be at for the exact same spot? If I start at -90, if I go 720 out, Ash, how far would we be? I'm sorry, what? That's 630. That's correct. That's 630. The other thing that you can do with these is just take where the start value is and add the period to it. So I'm at -90, just in your calculator, -90 plus 720, and I'll tell you your degree measure. So we'll be out at 630. Now we play our games of halves, halfway between -90 and 630. Halfway between -90 and 630. What's our degree measure? Sergio, where are we at? Now you don't learn, once again, you don't learn, and this is for everybody, we don't learn this class by just writing down what I write on the board. That's not learning. That's not taking notes. That's not effective notes. I'm giving you time to be able to work through the problems here. That's learning. What's halfway point? How'd you get 360? Well, I'm at -90. $270. Okay, so 270 is our halfway point. -90 plus 630 is 540 divided by 270. What's our y value going to be? Okay, let's look what a cosine curve looks like. Cosine curve, okay, we start at a peak, and then we drop down below, and then we go back up again to our peak. So we have a peak, we're going to drop down low, underneath, and then back up to a peak again. So where we're going to drop to? Well, I can't hear you. -2. What is our amplitude? 2. So 2, we're going to go 2 from our prime axis. Our prime axis is at -1. So we have to go 2 down from our -1, which would put us where? -3. So 270 will be at -3. My other two games of halves, between a peak and a valley, you'll cross the prime axis. And then valley and peak, you'll cross the prime axis. So the next two games of halves will put you on the prime axis. But that's one of those values. 90 and 450. And I put my y-intercept in at 0.4. So if I look at my graph, it should go through that y-intercept at 0.4, which it does. If you had a value of -3.5, either your graph is wrong or your y-intercept is wrong. Because if I had it down there, I'm not going to go down here and then come back up and go over to here. Let's look at a negative sign. amplitude period, vertical horizontal phase shift. And your y-intercept. Quentin, what's your amplitude period? Think 360 divided by 3, we got 120. Here's our B value. Amplitude is the absolute value of our A value, which is absolute value -4, which is 4. Vertical horizontal phase shift. Skylar, what do you have? Okay, y-intercept. What do we come down to, Isaac? Value 1. So looking at our graph, we have an amplitude of 4. We have a vertical phase shift of -3. Okay, so we're going to have to be a little bit more bottom heavy. Okay, so we need to be a little bit more bottom heavy here. And that's how you can judge this. Take a look at your amplitude and the vertical phase shift. Now we'll tell you, can I stay pretty much in the middle, or do I have to be top heavy, bottom heavy? Now the period's only 120, so I can make my spaces a little bit bigger here, and if the period's 120, I can probably just count out by 30s. If you want to count out by 90s, that is fine, but I'm going to count out by 30s. If you want to count out by 90 and divvy into thirds, that is fine also. But when the period is small, like a 120, or period of 90, you can count out by smaller increments. Drawing your prime axis. Second thing, we look at our horizontal phase shift and our sine curve. Where's our start value at here, Paul? What degree measure? 30. And do we start on the prime axis or peaks and valleys? We have a sine curve. Prime axis. So at a value of 30, we're on our prime axis. Third thing, where do we end up at? Lucas? 100 now? 150. We'll be on the prime axis again. Play our games of halves, halfway between 30 and 150. Ella, what's our degree measure there? 90 degrees. Where will our y value be? Sorry, what? Nah, not -7. Now remember, sine curve, we climb the hill, then we go down, or we go down and climb the hill. Huh? No? Sine curve, we're going to go up, down, back up, or down, up, back up, or back down. We're going to go up, then we're going to cross coming down, then back up again. So it's going to be up, up, or it's going to be down, up, down. Don't overthink. Yeah, we're going to go down first, then we're going to climb the hill, and we're going to go up. So at our gains of halves at 90, where will we at then? At -3 still. We'll still be crossing the prime axis. Okay? Since we have a negative with our sine curve, we have to go down first. So Ethan Stutz, where will we be at? -7. That will be our -7 at 60 degrees. And our gains of halves one more time are at 120. We have to go up 4, which would take us to what, Grayson?
1.
Up to 1. We look at our y-intercept. Our y-intercept is a value of 1. So if we drew our curve in, we go down first and back down, but we want to take it back up to our spot up here, take it back up to the y-intercept. Once again, that should be a natural flow into that. With the cosine curve at the very bottom, okay, when we have a coefficient to our theta, what we have to do is we have to factor out that coefficient. We have to use some algebraic skills to factor out that coefficient. So we have theta. Now how do we factor this out? Well, we factored out, we have to divide by 1/3. So we're taking the value of 10 and dividing by 1/3. If we're taking 10 dividing by 1/3, that is 10 times 3, or a value of 30. Okay, once again, algebraic skills, factoring out the greatest common factor, undoing your distributive property. Once again, with a negative cosine, we will start at a valley here. We're running out of time quickly here. We will start at a valley. So we have 360 divided by 1/3, which is 1080. Vertical phase shift of 1, horizontal phase shift of 30 degrees. this is going to get very tight with respect to our graph. I'm probably not going to give you a graph that's going to get this tight because I have a small horizontal fascia and a big period. Homework on the back is page 53. You have problems 1 to 8. Problems 1 to 8 on page 53. Once again, every time, find the amplitude, find your pertinent information, find all your pertinent information. Find this every time. And go through the steps time and time again, the exact same steps over and over again in regards to getting your graph down. You have page 53, problems 1 to 8. Questions you have? All right, BD has done.